R-CADT, Research Center for Advanced Decision Technologies, a division of Hypothalamus Artificial Intelligence Incorporated, is pleased to invite you to participate in the postgraduate level course. Machine Learning and Optimization, using GAMS Mathematical Programming Algorithms. A different course in Advanced Optimization. Hypothalamus Artificial Intelligence, HAI, brings real-world practice to academia to teach the implementation of optimization systems across the enterprise. This course focuses on imparting knowledge so that the student learns how to make the best use of GAMS as an optimization platform, taking advantage of the evolution of computing power and mathematical algorithms. The course consists of 2 modules, Basic and Advanced. Machine Learning and Optimization using GAMS Mathematical Programming Technologies. Structure. The advanced course Machine Learning and Optimization using GAMS technologies is aimed at training the participant in the computer technologies that are required to solve the problems that companies must face in long and medium-term planning, and in short-term and real-time programming, scheduling, of real organizational systems, using GAMS software platform. 2 modules are taught. GAMS Basic Optimization, training in integrated solving optimization problems using GAMS optimization technology. Most examples are related to real problems whose solution must be done with optimization models. GAMS Advanced Optimization, training in solving advanced optimization problems using large-scale methodologies and GAMS optimization technology. It is studied how to decompose a complex problem and its implementation and use using large-scale optimization methodologies, such as Benders, Lagrangian relaxation, Dantzig-Wolfe and cross-decomposition. The basic unit of the program is virtual classes, or sessions, focused on specific topic related to the use of advanced analytics. 1 module groups 10 classes. The estimate is 30 hours of training per module. The time spent on the course depends on the student's skills and dedication. In the GAMS Basic course, the student will learn how to obtain optimal decisions in the real-life problems, formulate mathematical programming problem and implement it in GAMS, make computer codes using structured mathematical modeling, SMM, methodologies and superstructures framework, organize the mathematical models to relational databases, with the input data and the solutions of the models, organize mathematical models that relate more than one optimization problem in sequential, and/or loops solution process, conceptualize time management according to the most appropriate type, discrete time modeling or continuous time modeling. Handle properly the GAMS tools, GAM IDE, GAMS GDX, GAMS Miro, GAMSPy, and GAMS Engine. Utilize different types of solver available in GAMS. Implement different decision problem formats, PL, MIP, MINP, NLP, PEC. Implement advanced GAMS options as disjunctive programming, bi-level models. Run sensitivity analysis in GAMS, and review the algebraic formulation and GAMS implementation of models that have been applied in real-life problems. Examples in energy supply chains and industries in general. In the GAMS Advanced course, the student will learn how to formulate bottom-up models based on partitioning and decomposition, for their solution using large-scale optimization methodologies. Implement several types frameworks for large-scale optimization methodologies such as dynamic programming, Bender's theory, Lagrangian relaxation, Dantzig-Wolfe decomposition, surrogate programming, and cross-decomposition. Study Bender's partition theory, its variations and improvement, dynamic Bender's SDDP, stochastic dual dynamic programming, GSDDP, generalized stochastic dual dynamic programming, and others. Conceptualize the implementation of stochastic programming and risk management models. Use of GAMS extended mathematical programming and rapid prototyping tools, and asynchronous parallel optimization using GAMS real-time distributed optimization. The course is aimed at professionals, data scientists, engineers, mathematicians, physicists, consultants, economists, software developers, who require and/or want to know the new current optimization technologies, according to the state of the art of computing, optimization algorithms, large-scale technologies and Industry 4.0. GAMS mathematical programming methodologies. There are multiple types of models based on mathematical programming that can be required by an organization, each of them for specific and complementary purposes. Multiple formats of optimization problems. Computable general equilibrium. Mathematical programming with equilibrium constraints. Advanced probabilistic models and econometric models. Support vector machines. Grouping, segmentation, and classification. Generation of synthetic random variables. Large-scale optimization models, and advanced stochastic process modeling. Despite their diversity, the different types of models meet a common characteristic: they can be formulated using algebraic expressions typical of mathematical programming. Traditionally, they can be solved using a solver based on the mathematical laws of constrained optimization. A low-level programming language in which the interface between algebraic formulation and mathematical programming solver is programmed. Currently, the best alternative is to use a high-level programming language aimed at handling algebraic formulations and interacting with the solver, like GAMS. Optimization technologies can be organized as follows. Optimization solvers. According to High, the most used are the commercial solvers, IBM Cplex, Gurobi and Express. The course will focus on the relationship between solvers and GAMS. Programming language. Products aimed at the development of optimization models, focused on providing the mathematical modeler with a way to implement specialized algorithms in certain types of mathematical problems, linear, nonlinear. For large problems, large-scale optimization methodologies are often implemented. For the development of algorithms, the following can be used. Low-level programming language, or high-level algebraic language. GAMS corresponds to a fourth-generation language, the first version of which was launched on the market in 1987. Optimization informatic platform, computer platforms that integrate all the computer aspects. Optimization expert system. Artificial intelligence-based platforms. Optex, produced by High, is one example. The last two computer platforms will not be studied in this course. Implementing algorithms in GAMS begins with the formulation of monolithic models that use a solver to solve a monolithic, integrated, problem. Mathematical models made up of multiple problems is the current trend. Its solution is carried out through large-scale optimization technologies. These technologies, high-level algorithms, are built around a high-performance solver, which uses current computational power and all the power of parallel optimization. This is a central part of the advanced course. Machine learning and optimization using GAMS technologies. Theme plan. The instructor of the course is Engineer Jesús Maria Velásquez-Bermúdez, Ph.D. The founder and chief scientist of High is the creator of Optex, his most important technological work. The video. The history of Optex, the optimization expert system. From the simplex method to multi-problem models, Optex expertise meets artificial brains, moving toward mathematics-based general artificial intelligence. And the article Optex, where optimization expertise meets artificial brains. They present the history of Optex, which is the professional history of Jesús Velásquez-Bermúdez. The table presents the topic plan for the basic course. The module teaches the student how to use GAMS correctly, mainly to develop monolithic models. It includes the connectivity of GAMS programs to databases, to read parameters and sets, and to write optimization results. The table presents the topic plan for the advanced course. This module focuses on teaching problem solving using parallel optimization, which is the state-of-the-art of optimization, according to computer technologies, that concentrates on generalized parallel processing. High is convinced that monolithic modeling is a thing of the past. Parallel optimization is supported by large-scale optimization methodologies. General conditions. R-CADT and/or High issues a certificate signed by the scientific coordinator, for which the student must participate in at least 20 conversation sessions. The price of each module is 1,000 US American dollars. Student discounts are offered as follows: 50% to undergraduate students, and 20% to master's students. The course may be taught under the in-company modality. In this case, prices vary depending on the number of students. Companies, public bodies, universities and research centers are considered. In the case of professional and trade associations, research centers and universities, HI proposes bilateral agreements analyzing each specific case. In university courses. For academic institutions, this course is an opportunity to modernize their operations research courses according to the state of the art, updating professors at the level of doctoral knowledge, implement postgraduate courses in their institutions, with the help of an in-house professor dedicated to this purpose. Access the know-how of real-world application, and truly leverage digital, high-level, AI-powered education. Economic agreements have special conditions with the aim of promoting advanced knowledge in developing countries. If a student is interested in receiving direct advice from R-CADT, the following conditions apply to projects. The value of the advice on a project will be between $500 to $1,500 US per semester of the duration of the consultancy. The value will be defined once the student submits the project proposal. Taxation. The above values do not include withholding tax and value-added tax. If necessary, these amounts must be charged to the value of the course in such a way that the net payment is equal to the stated rate. Payments via PayPal or similar have a surcharge of 10%. Specific conditions. Academic inquiries are made directly to the Scientific Directorate, and special agreements and administrative consultations are carried out with the Administrative Directorate. The student receives permanent access to all videos of the recordings of the class sessions. Documents specially written for each of the sessions. PDF copy of the presentations used to record the videos. Access to a library of papers with specialized documents on the topics dealt with by the diploma course. R-CADT invites you to learn about other courses in advanced analytics and mathematical programming. Courses for the energy and mining industry. Electrical sector, systems and wholesale market, renewable energies and smart grids, oil and gas, and mining and metallurgy. For the industry in general, industrial production, bio-industrial production, marketing and sales, and transport and logistics. For more information, please contact Ms. Catherine Rojas or Ms. Andrea Velásquez-Pardo, whose contact details are presented in the image. Thank you for your attention. Alfred North Whitehead affirmed, "Algebra is the intellectual instrument which has been created for rendering clear the quantitative aspects of the world." The importance of this phrase lies in the fact that all modern mathematics is based on algebraic models that become algorithms, that use all the power of current computer technologies. Thank you for your attention.